Hey everyone, so today we're going to discuss DNA replication in prokaryotes. Here's the list of key vocabulary terms that are important in this section and come up in this video. And here are 3 examples of DNA replication in prokaryotes. Here's the link to the video that we're going to watch next. Hey everyone, so today we're going to discuss DNA replication in prokaryotes. So, as we know, synthesis of DNA replication in prokaryotes only travels in the 5' to 3' direction. As you can see from our double helix here, the enzyme helicase unwinds the DNA double helix at the start of the replication fork. From the replication fork, 2 strands are synthesized, the leading strand and the lagging strand. Very small, single-stranded binding proteins coat the single strands of DNA near the replication fork to prevent the single-stranded DNA from winding back into a double helix. The DNA polymerase III enzyme is responsible for adding nucleotides in the 5' to 3' direction. The RNA polymerase enzyme synthesizes RNA primers. The leading strand can be extended by 1 primer alone, but the lagging strand needs 1 primer for each Okazaki fragments. You can tell this strand is the lagging strand because it is composed of Okazaki fragments. The overall direction of the lagging strand will be 3' to 5'. If the DNA polymerase I enzyme can no longer perform its 5' to 3' exonuclease function, then the RNA primers are removed. DNA ligase enzyme seals the gap between Okazaki fragments on the lagging strand. Overall, we can conclude that the direction of replication occurs from right to left. And here are my references. Thank you so much. Hope you enjoyed the video.